Hi everyone, my name is Anna, and today we are going to learn about derivatives and the shape of graphs. The goal here is to what kind of information lies in the derivative of a function that can help us to better understand the function, or as I write it here, understanding the function's behavior through its first and second derivative. We will see that derivative is not just a formula, it's a very powerful tool to study the world around us and to learn about so many things about the function that we are studying. As an example, let's assume that we have a very big and great company, and somehow we know that the function that gives us the profit of the company over time is given by this relation. So this is the function of profit over time. So looking at this function, we might have no idea of what's going on. How should I interpret the profit over time? But yet we have some very important questions because we want to know whether our profit is decreasing or increasing. We want to know when does the profit reach a maximum or a minimum, or we want to know that when does profit stabilize or change its direction. These are very important questions if we are running the company, that looking directly at the function itself, we have no clue to answer this question. This is where the derivatives come into play, and working with first and second derivative, we are able to answer this question about any complicated function that looking at this function, we have no idea about their shapes or the shape of their graphs. But working with the derivatives, we can extract information about useful information about that function. Now, we're going to see what kind of information we can derive from studying first and second derivatives. Well, going through the first derivative, the sign of first derivative tells us if a function is increasing or decreasing. If the sign of a function derivative of a function is positive, we know that wherever the sign is positive, our function is increasing. And when the sign of our function is negative, we know that our function is decreasing. As a very simple example, let's assume that our function is x squared. If we compute and if we calculate the derivative, we see that f prime equals 2 times x. We know that 2 times x is positive for the values greater than x, and it's negative for values less than x. So for values greater than x, we can derive this information that our function is increasing, and for value less than x, our function is decreasing. As we know the shape of graph, because this is a very simple example, we are all familiar with x squared function. We know the graph is look like this, and we know that at this interval the function is decreasing, and at this interval the function is increasing. So it matches our intuition, and it shows that very quickly we can learn something about our graph, about the graph of our function, knowing the derivative. I jump to an example of the second derivative before ending my video. So second derivative, also the sign of second derivative gives us some information about the our function. It gives information about the concavity of function, whether it's concave up or whether it's concave down. So again, looking at the example, this time looking at example minus x squared. If we look at the second derivative would be minus 2, and as it's always negative, we conclude that our function is always curving down. And as we look at the graph of the function, because again it's a simple function that we can draw, we see that it's true. Our function is always curving down because the second derivative is negative here. So at these very simple examples, we learn that without knowing much about our function, the graph, without seeing the graph of our function, by studying the derivative, like first derivative and second derivative, we can derive so many useful information about the function itself. Thank you.